Okay, so I'm going to introduce Simon Elwen here, who's going to talk about the work of Guilherme. Many of you will know, but some of you may not know, that Guy died earlier in the year. He was a key member of our group of Sea Search. He was a good friend to all of us. He was a husband to one of us. And it's very emotional for members of our team and everybody who knew him. He had suggested doing a plenary talk at this conference on the day that he died. And so for us, this is a really important one, to be able to demonstrate the work that he did through his career. A lot of that was done before he came to Sea Search, so he came to us as a postdoc, and so Simon has diligently gone through his history of work, his body of work, and summarized it to the best that he can do, and I'm sure it's going to be a very fitting talk and a very good talk about his work. Guy came to us as a postdoc working on Indian Ocean humpback dolphins and developed into his machine learning skills, and he went on to do another postdoc with Emmanuel. Okay, so I'm going to hand over to Simon, who will give you insight into both Guy's work and also, I think, his personality and why he was a wonderful human being, and we're very sorry that he isn't here today.
Thank you. As Tess says, it's a challenging subject to try and get across, to represent somebody else's work in a way that best sort of gets across their passion and their interest and accurately reflects it. So the title that Guy had proposed was the naturalist toolbox, and I've taken that approach as well. And the sort of message, I guess, of the talk that I hope I can get across is that having lots of different tools at your disposal, skilling up in a broad range of fields, can really bring a useful and powerful perspective to your research. So Guy was a biologist, a photographer. He was very much a surfer and a friend, as Tess has already said. I would encourage you to have a look at his website and his GitHub repository. Sorry, I have to step on the microphone if you have the chance. Well, you do have the chance because it's up there. He also developed some very useful sort of Python coding tools for a decimator and a few other useful things, and a nice piece of machine learning software that we're trying to make sure stays active and is usable. Sorry, someone's cutting onions back here. It's terrible. So what is bioacoustics? I mean, this is an interesting concept as a conference. I've been to a lot of different conferences over my career, and often it's a marine mammal conference, so you get lots of different research tools focused on one group of animals, whereas here we have the opposite. We're all using different aspects of a very broad field of bioacoustics, and depending who you are and what your background is, you might be approaching this field from a background of physics, mathematics, anatomy, morphology, phylogenetics, ontogeny, animal behavior. A lot of talks I've seen here have been more in the ecology, soundscapes, and I was just in a conference in the Netherlands a few months ago where there was an entire conference focused on detection and classification and more machine learning than you could ever hope to listen to in a week. I never need to hear the word CNN ever again in my life. Sorry, I'm trying to sniff in there. Guy's career and his research interestingly covered a remarkably broad range of these research tools, and so I'm going to reflect on some of those now. So Guy is a Brazilian. Tess has known him now since end of 21, 22? Oh, I can't remember the years. She still can't say his name. But that's because she's English. She can't pronounce anybody's name. Don't be offended by it. She's been living in South Africa for 14 years and can barely get past by a donkey. But back to Guy. So his BSc, MSc, and PhD work were all done through the University of Rio Grande do Sul in Brazil. His master's work focused on on sort of a phylogenetic species in fish, actually, before moving on to work on the Franciscana, which is one of the most endangered dolphins in the world, and their biosonar, and then sort of expanding that into a more sort of general phylogenetic approach across different dolphin species. He also did a lot of work as fisheries observer, marine mammal observer, and extensive field work. So he really came to us as a sort of widely skilled up, useful, broad background kind of person before joining us as a postdoc to officially work on the acoustic classification of whistling dolphins, because I'll get into why that is later, and yeah, lots of other stuff. So just some pictures that I've poached off of Guy's Facebook, and Nachi, that's his wife. If any of you have ever dissected a dolphin, I've dissected quite a few in my life, done quite a lot of necropsies and things, and usually I approach it with a fairly large knife, and it's quite fun at that scale. But getting into the actual fine scale dissection, which is what's needed for the sort of assessment of sound structures, is really very painstaking work, and I've got a lot of respect for Guy and people who can really get into that sort of fine scale anatomy approach of things. So a lot of different skills, a lot of field work, really nice broad cross-section of the field. And also a very skilled photographer. But when we got Guy to us, this is what we knew on paper. Of course, you have a couple of interviews, you go, cool, you seem nice, you seem professional. And then this sort of is sort of switch it down a bit background. So we were going through a bit of a phase with our YouTube. Guy flew into Cape Town. I think we got in, picked him up in the field, basically the next morning. So the fact that he was willing and able to do all of these things, and he was always the first one to put his hand up and say yes to things. It's just a typical day in the life of one of our field trips. The new interns and students on boats. We were students, not in the latter one. Yes. We do occasionally go on boats. So we were working with group on backgrounds here. We took some pictures. I was driving a car. Just a really fun day out. We did a lot of fun. Well, so like a floating, it's a sound trip on a stick. It's working with a boat. Just get these other whales. It was fun to be out in the field and just with a tricky stick background. On the genetics. So we are lucky here. It is not quite time yet to have down to the ocean. So, yeah. Things take a little longer than that. But we were going through a YouTube page, we're expanding on our YouTube channel. So a lot of education stuff in there, as they can see, but there are quite a few fun field videos. Selling green knowledge. I think it's fun, but boring. We have good stuff, but that's yeah. There we go. It's very nicely off. Yeah, so then it's along there. So Guy was really involved in all the work that we did. He said to put just on what he was working on. But just sort of going back to try and cover some of the work that he did early on. This conference so far, everyone's been talking very much in sort of ecology, soundscape, by animal behavior topics so far. But there's a huge amount of anatomy underlying this, and I remember we had a workshop from David Reeby, was it last year, where he talked about studying bioacoustics without an understanding of the sound production mechanisms. It's a bit like trying to study race cars without knowing what engine's under the bonnet. And that's something that really stuck with me from David or David, sorry, he's French. Did I say that right? And a lot of Guy's early work focused on really this anatomy and the phylogenies of stuff. So his master's work focused on the Franciscana, as I said, a highly endangered dolphinus, and lives in very coastal waters of South America and up rivers. And the toolbox that was used in this work that he did involved strandings, collected strandings data, doing the dissections, cling filming dolphins, running MRIs and CT scans, and putting that data back together using various 3D modeling software. I did include cling filming dolphins because it is quite a unique skill set, and not a lot of people are good at it. You've got to be very careful in doing it. We've done one cling film dolphin in my career, and especially when you're walking through public hospitals with a cling film dolphin, you've got to be very careful that you don't let the blood drip out. So it's a unique but very useful skill that is surprisingly transferable if you've ever watched Dexter. And of course, the dissections, as I said earlier, is a real skill set. So a lot of the work here, he was dissecting through, sort of these taking multiple layers of the dolphin's head from fetuses all the way up to adults, and sort of you then take the slices and you put them back together afterwards and build these into 3D models. So if you're wondering what those were, sorry, to me they were obvious. Should have said those are dolphin heads from above and from the side. And so the results in this study showed that although these Pontiporia have highly symmetric skulls and actually very asymmetric soft tissues, so they're sort of producing sound through very different sort of channels, and that the sound detection structures, if you didn't know, dolphins actually hear through their jaws. They get most of the sound in through their jaws, but particularly, hang on, I've got a laser, through the sort of posterior part of the jaw, and the front of the jaw is where the teeth and the foraging structure. So from evolutionary perspective, these sectors often actually evolve sort of independently, and that's what some of this work is focused on. And so one of the factors I picked up here is that there were these real ontogenetic changes in the sound production structures during the maturation process, and that showed that this aligns with a diet shift in these animals from juveniles to adults. And so one of the problems they're having is a lot of these animals are dying in nets, and it's mainly the juveniles. And so one of the underlying questions here is like, why is it the juveniles? What's going on? Is it a physical problem? Is it something we can mitigate in the field? And the answer is essentially baby dolphins echolocate badly from evolutionary perspective, and there's not a lot you can do about it. Take the nets out the water. And then this work was expanded using similar skill set, gross and fine dissections, a lot of slides, histology, so actually like slicing up baby dolphins. That doesn't sound as sexy when you say it out loud. Slicing up baby dolphins into very fine slices, and then putting it all back together in a computer to build 3D models, and really sort of following these structures as they develop. So a huge amount of work goes into collecting the specimens behind these things. And the sort of results coming out of this, building these cool 3D models, so working across different taxa. Sorry, this screen's surprisingly small. Pontiporia, so Franciscana, harbor porpoise, and Legorhynchus albirostris, a white-beaked dolphin. So these dolphins have very different sort of phylogenies, different family trees, and different structures in the way they evolve. And these three different families show quite distinct differences in how they form their sound-generating structures, and how they evolve. And the hypothesis is that the broadband vocalizing dolphins have evolved under more relaxed constraints for the directionality. So there's a lot less evolutionary pressure on these animals to have focus sounds, and so they're much better at detecting some of the sort of fine-scale things in the ocean, like gill nets, which is what's causing all the problems. While the narrowband high-frequency species, so these are things like the porpoises and the Commerson's dolphins and the Franciscanas, that only echolocate at very high frequencies, are much more constrained in how they can, and less adaptable, how they can adapt to sound. And so then this work Guy took out with some of his colleagues. They sort of expanded this into a broader evolutionary framework, looking at rostrum morphology and how important it is to sound production. It's not just in the melons and the musculature, but the actual rostrum plays an important role in how this development occurs, right? Sorry, I feel like I'm butchering this slightly. This is not work I'm that entirely familiar with. And this is related to the development of these specialized directional sound emission systems. So the echolocation of these animals is very directional. It can be, and for raptorial specialists, that's those that hunt and catch fish, as opposed to the suction feeders. This sort of the development of these specialized sound productions systems really only happens postnatally, which again results in across these species that young animals are particularly vulnerable to nets, and that these more long-beak species, which include things like the Franciscana and the humpback dolphin, which is where what he was working on here in South Africa, worked here with Stephanie Plun at the Port Elizabeth Museum, essentially makes these nets acoustically invisible to young animals. So from a mitigation management point of view, you can take this phylogeny and evolutionary and histology and real lab-based work, and it always comes back into the real world, which I think is something a lot of us work with here. So sort of stepping out of the lab, out of the hospital, out of the dissection room, and getting into the field, taking what we know about how animals produce sound and sort of stepping it out into the field and sort of looking at how these get put together with behavioral acoustics. So this is a work that was actually part of Natalia's, which is Guy's wife. It was her master's project, but Guy played an important role in this project, both in the field and helping with the write-up and what have you. And his role in the field was particularly drone operator in this project. I really like this photo, just because it looks like there should be a big explosion in the background. So one of the probably like Hollywood photos. And I actually would encourage all biologists to get more hero shots in our profile photos. I think there's far too much nerding around in closed rooms. We really need more of these hero shots, the Michael Bay approach, We do some cool stuff, and we're very lucky that we get to do this. It's great seeing you guys talks on elephants and cheetahs and running around in forests and doing gross things in forests. Hot and warm, not my thing. So this is actually, you may have heard, sorry, I could have said on the microphone. So the fishes in this area of Brazil, there's two places in Brazil where these dolphins cooperate with the fishermen. It's really unique globally. It's something you've probably seen on a documentary somewhere. It's not something I'm aware of happening anywhere in Africa. Please do let me know if anybody knows of something. But what happens is the dolphins, in this case, it's only about 10 individuals. They sort of stays within a social network within this broader population, and they chase the fish in, and then the fishermen respond to the cues of the dolphins, the behavioral cues. And recognizing those cues of when to throw your net is something that's passed along the sort of small group of fishermen. So this study was in a place called Tramandai Inlet, which is a smaller, less well-known site, which as I said to Natalia's master's work that was done. And it was quite cool in that the dolphins, they sort of classified 27 different behaviors with 3 main movement types, with the dolphins milling and prowling and sort of holding themselves in the current. And the study species here was as much the fishermen as it was the dolphins, which brought quite an interesting perspective into it. It's very different. We all work with animals. It's a bioacoustics project, but if you've ever tried working with people or fishermen, that's where the conservation happens. And it's a different skill set, and it's something that we as biologists are often not trained in. Speaking to people, there's a lot of people in the field that are really bad at it. I would possibly include myself in that at times. But what I particularly liked about this, one of the cues that the fishermen responded to was a head slap from the dolphin. So when they're ready to go, they'd be like, and then they'd start casting their net, which I just find quite entertaining. So this behavioral acoustics is something we've done a lot in South Africa, and some of the sort of skills and experience that he worked with on this project moved across to the work he was doing with us. But one of the skill sets that is quite unique in our field, and it was interesting hearing Martha mention it earlier when he talked about learning from the guides, is this interviewing fishermen and using local ecological knowledge. It's something that is not you don't come across a lot in the bioacoustics field. It's used a lot more in ecology, sort of interviewing people and finding out, have they seen a manatee or have they seen a specific dolphin or bird in this area. So one of the projects that CSearch has done recently in the last few years was started up a field research project in Mozambique at a place called Ilha de Fogo. It's quite far to the north. So in case you're not aware, Tess and I are a couple, and so we now have to sort of negotiate who goes on which field trips and who gets to look after the kids. So this was sold to me as a multifaceted exploratory research trip with both terrestrial and marine research goals, with potential for long-term collaboration, and Tess was going to go and do the hard work in this hot, sweaty place, probably mosquitoes. I'll look after the kids at home. So me on the couch, Tess sending me pictures that basically looked like her with the boys having a grand old time in Mozambique. So I would like to point out, I think this was 2022, and I haven't seen a single paper come out of this research trip yet. Just saying. And it culminated in this true classic of a photograph, which, in case it's not obvious, interpretive dance might not be. I think they were trying to spell out research, and conservation. But there was actually some work done. We do still need to get the paper out. So everything from recording birds, this is Guy filming birds, and so these recordings would feed into our bioacoustic sound library that we're trying to develop. Sounds like birds. Recording birds, so getting the video of birds calling. So trying to really step away from...
Recording in progress.
Thank you. We're trying to, Tess is going to talk more about this in her own time, but and Natalia is going to be reporting on where we've got to with this. So the idea with this project is that we have videos of the birds calling. It's not just recording them in bushes. This comes from our marine mammal background. We are very cautious about assigning calls to species in the marine mammal field. I do not understand birders who are just like, oh, it's a starling in a bush 200 meters away. And I'm like, who told you that? Like, I don't know. I want to see it coming out of that dolphin's blowhole. There was also, come on, wake up. What's going on? Your machine's broken. Oh, that's why. There was also quite a lot of crawl around the bushes, photographing things. These are Aaron's photos. He did a very nice job putting them together. This actually is on iNaturalist, I'll give you that. There's a nice little lump in iNaturalist off northeastern Mozambique of all the things that we've seen there. And interviewing the locals.
Welcome to Fire Island. I am the Green Turtle. Oh yeah.
That's Guy interacting with the locals. But and most importantly, the one thing you of course would never forget if you're a bioacoustician is your hydrophone. Except of course they forgot the hydrophone. So we had the sound trap for recording the animals and the audio moth for recording the animals, but they didn't have a hydrophone for actually listening and trying to find the singer. So they were trying to find singing humpback whales to get a sample of the song from that part of the world. And of course, if you don't have your cable hydrophone and you need to find a singing whale, you need And so Guy got volunteered to go dive in the water and dive down to 10 meters and listen to whales, and then come up and give it a rating out of 10, and then move the boat and try and see if it got louder or softer until they eventually managed to track down a singing whale, which I believe worked in the end.
Oh, living his best life.
Worked like a bomb. But this is Guy in a nutshell, really always out there first to get in the water. But one of the really unique angles he brought to this trip and to a lot of the other work he did with us is working with fishermen. He really had a great touch with people, and there's a lot of indigenous fishermen, traditional fishermen in Mozambique. It's interesting because I've done a lot of my work in Namibia over the last sort of decade or so, and we don't really have this sort of fishery in Namibia. And of course, Guy, being Brazilian, speaks Portuguese, and could really get out there and was just meeting the fishermen, interacting with them, getting to know them, and again learning something really interesting about the fish. So asking the local fishermen which ones make noise.
Mestre nos sons.
And here's a fisherman doing the fish noise.
Como que ela faz?
That's brilliant.
Obrigado.
Just say because we're interested in the sounds, yeah. It's cool.
A gente estuda o som que eles fazem na água. A gente bota o microfone embaixo d'água para gravar e a gente escuta eles falando.
For the whales, particularly.
E tu sabe se tem outro que faz som aqui? Qual? Qual deles outro que faz som? Só esse? Os outros não fazem som. Não, a garopa não faz som.
Ah, okay. So, you see, this one makes sound, the other ones don't.
Yeah.
That's what I understood. Okay, that's cool.
What kind of fish are these ones? pedra. Troca.
It's actually potentially a very useful way of approaching it. As scientists, we often, back in the old days, my supervisor was very like, if you didn't collect the data, you can't trust anyone. But over my career, I've certainly come around to using local ecological knowledge and citizen science more and more, and it's something that's really cool seeing rolling out in the bioacoustics field. And having that human touch to go out and interact with people and speak to them and learn from them is not something that we can all do, but a really powerful skill set to please include in your toolbox if you can. And so we're sort of stepping from here back into some of the work we've been doing in South Africa. The reason Guy was actually on the payroll was to work on humpback dolphins in South Africa. So Susa plambea, another typically bad name for a dolphin, the lead-colored dolphin. Not many people know what these dolphins are. They do have a humpback, so obviously, they got called humpback dolphins. But they are very rare. They're very elusive. We only think there's a few hundred in southern Africa. They're quite endangered. They're extremely coastal. When you're on a boat, you often see them like this really, really close to shore, like often with the waves on the wrong side of them. And so it's a challenging species to work on. It's very ineffective to work on them from boats, although that's a traditional way we've been doing it. You do boat surveys. You can go spend 2-3 weeks in the field and identify 12 dolphins. It's quite inefficient. And so we've really been pushing passive acoustic monitoring as a way forward with these species. Perhaps not immediately obvious, but the colored bit in red here is where the range of these animals is. It's so coastal, they very rarely get deeper than 15, 20 meters of water depth. So they kind of have a range that's more akin to like an oyster or kelp than what you might think a dolphin actually does. So if you sort of look at lion map or rhino map on this, there's huge chunks where rhinos and lions and typically endangered species do live. But some of the dolphin species we deal with around Africa, particularly the humpback dolphin, are very endangered. And on the west coast, we've got the bottlenose dolphin, so that population also probably quite endangered. And so the project that we've been pushing that test developed a few years back, that was the funding that Guy's postdoc came out of, was called SWORD, because all projects need a sexy acronym. Stands for Signature Whistles for Occurrence, Recapture, and Density. So dolphins, or many dolphins, have these individually unique calls called signature whistles, which in essence act like a name. The Sasha and Jack can correct me and use the proper definitions tomorrow, but dolphins run around yelling their own name a lot. So it's really handy as a way to potentially record individuals, not just a dolphin was here or a humpback dolphin was here. You can say dolphin 12 was here, or if it's got a better name than that, I don't know. Bob. This is Bob the dolphin, and I don't know why. Where are we? So you need quite a lot of tools to work on these animals. You need boat skills. You need a sort of, the willingness to go work in surf zones. You need to be able to manage a lot of different equipment. Acoustic work, familiarity with signature whistles, how to identify them. You need to be able to do photo ID in the field. So we're really getting out into the field skills here, understanding animal behavior. And what we were trying to do here was look at sound localization. So we were trying to get these unique species groups because we were trying to build a classifier, so we had to have confirmed species recordings, and that is irritatingly and surprisingly hard. So we did have this ambitious goal of recording individuals. So Sasha, Tess, and Guy spent a lot of time in Mossel Bay, particularly with 4 hydrophones dangling off the boat on chains. And I promise you, do not want to be sitting with your engines off and 4 hydrophones on chains in the water when the waves look like that. So although they tried really hard, and Guy sort of took on a lot of the localizing and PAMGuard and got it working quite nicely, ultimately we didn't, I think, get the sample size to really sort of make this work. It fed back into this. By the time you've got the dolphins and the weather and the hydrophones working all on the same day, you end up with a sample size of 3. And the other challenge even is when they were getting single hydrophone recordings, there'd often be a group of common dolphins swimming past in the background running the recordings. And so it's this classification side that's really challenging. And so the goal here is, this is Mossel Bay, which is about 400 k's east of us here. A lot of humpback dolphin sightings around the bay. And this is Sasha's PhD. She's going to talk on it tomorrow, Thursday. All right, and so Guy's role in this project was looking at the detection and classification in these long-term recordings. So the goal of the project, the SWORD project, is to just dump out a bunch of hydrophones, let them do all the hard work, and then we'll just quickly process the data at the end and identify the signature whistles. Easy peasy, right? Yeah, you're a bioacoustician. You're not fooled by that. It's not easy. And so a lot of this field work was actually recorded with YouTube phase, and Tess filmed particularly Guy and Sasha, it's quite fun to watch these if you get really bored, because you can sort of watch the mood deteriorate through the field trip. Where at the beginning, it's a fun idea, and then by the end, it's only Tess going, "How's your day going, Sasha?" And she's like, "Fine." It is quite entertaining to watch those in retrospect. But we're trying to sort of get a bit of the whole like field work in action for people, because just obviously filming ourselves on our computers is kind of boring. And while they were in the field, it wasn't just an acoustics project, because we work on marine mammals, so there's a lot of photo ID, a lot of recording behavior at the same time. And these are the humpback dolphins, or some of them, and you note like a lot of them are just covered in injuries. This is possibly entanglement. This is a shark bite. And quite a few of these guys had broken rostrums or noses, and they've got these really long noses. And of course, with Guy's background, he was like, what's going on here? How do these animals echolocate? How are they hunting with these, with these broken rostrums? And so he sort of started digging, and it turned out this was quite a long piece of string when you started pulling on it, and we were getting got a little bit sidetracked by this project. And in the end, Guy put this into a really nice paper looking at rostrum abnormalities across the species, and it came out as about 25% of the animals we were identifying had broken or deformed rostrums, which is really quite incredible given the importance of, this is the mouth for catching fish. And this is a structure that plays an important role in echolocating and navigation, right? And so Guy really sort of led this work and brought obviously a lot of his insight from Franciscaners, which are similarly long noses, and his ontogenetic background. But really amazing. So that some of these animals survive for quite a long time. This animal here, it's a female from Richards Bay. Sorry. She actually managed to survive, I think it was 7 years she'd been in the catalogue with this broken rostrum. She'd successfully raised a calf. And then had another calf that was about 4 months old when she was caught in the shark nets and died. Sorry, that wasn't a good story. It was an interesting story. She did survive. But it is amazing that these animals are surviving with a nose that looks like that for multiple years in the environment. And so we're like, what's the cause? Obviously there's no clear cause, because of humpback dolphins, and it's one of the things we've really been struggling with the species. Like, we know they're endangered, we know the numbers are decreasing. The work we're doing here forms part of a broader consortium of researchers working together. I've just zoomed in on this bottom section so you can read it. There really wasn't a standout reason for this. They do have incredibly high pollutant loads, and Guy was pointing out that animals with very high pollutants often end up with brittle bones, so it potentially makes them more vulnerable. A couple of them did have fishing line involved. Some of them definitely entangle, so that probably plays a role. We put forward and discussions about, is it potentially fighting with each other, or interacting particularly with bottlenose dolphins in the Pacific, bottlenose dolphins, which are increasing on that coastline, or with sharks, because a lot of these animals have shark bites. And as with so many things, I think it's actually a bit of a multifaceted answer to this. And the other unusual thing that these guys do, Guy managed to dig out some interesting sort of papers from back in the 60s, where there were a few animals in the Port Elizabeth, what's called Bayworld, Port Elizabeth Museum, that they use this nose down. They really stick their head in a reefy rocks and reefs to forage things out. A lot of dolphins do that in sand. And we put forward that perhaps actually these animals are like getting stuck occasionally and snapping their noses. So it's just one of the many things that these dolphins face that is really challenging. But getting on to what Guy was actually meant to be doing, now that we got sidetracked by rostrums and humpback whales and everything else, was really trying to classify these animals acoustically. And it's really challenging because, as I mentioned earlier, there's a lot of other species in the environment. So we did get a paper out of this, and this analysis worked really well. And Guy really wanted to push us down a machine learning path. Tess and I were quite hesitant. We were like, just use PAMGuard. PAMGuard works. But he really pushed with this, and we've got Emmanuel Defork on board, who's a colleague at Stellenbosch, actually just down the road at Ames, and he's really been leading with his group a lot of the machine learning work in the field in South Africa. And it's a pity he couldn't be here, but Loren from his group is at the conference at the moment. And so, as I said, we have a really high diversity of cetaceans in this country, and where our humpback dolphins live in the south, these are these sort of east coast species, and here at Cape Town, north, we get west coast species, but a lot of them overlap literally around the city of Cape Town. So it's really great if you're a tourist, but it's really frustrating if you're a bioacoustician, because all of these guys whistle, and these ones whistle. West coast, they're decent dolphins, because these don't whistle. These are narrowband high frequency. and these do whistle. So on the West Coast, it's easy to tell your animals apart, but on the East Coast, it's a nightmare. And so what Guy had done was we had all this extensive field work to build a sound library of nice, unique, recorded species of this is definitely a humpback dolphin, this is definitely a common dolphin, which actually took years of work to build that library, which is available if anybody wants to collaborate. Is it? I think so. Bianca's currently working on this, testing it with BirdNet. Where's Bianca? You're not hiding. There you are. And so from Toolbox point of view, this was now really getting into the acoustic software. So we've gone all the way from, how do animals make sound to collecting in the field and linking with behavior and really sort of sitting on the computer and getting into machine learning and building even into these supercomputers to run some of this. And so Guy, working with Emmanuel, took a whole, tested all these different versions of how to sort of break down the sounds, trying to future-proof it by looking at higher resolutions and longer time windows, which is what currently limits a lot of the sort of algorithms when we put this together. Ultimately, that's a laser, I'm pushing the wrong button. Ultimately, it was a 2-second window in the 90 DPI that was working most optimally. But one of the cool things he did that I think now is becoming more common, correct me if I'm wrong, but was actually including the soundscape. So not just looking at the whistles. When Guy and Emmanuel were sort of pulling this together, this was quite a novel approach at the time. So it's called augmentation. You're basically not just using the call itself, you're including background noise. So you need that recording of the environment, because when you actually start to understand what these machine learning algorithms are looking at, they're literally just looking at a picture. And at the conference we were just at the other day, the DCDLLDE, I can't remember the acronym. No one can. It was really interesting being in a room with these are the top researchers working in the field, and nobody was producing essentially a better model than this. There is just a maximum limit to how good you can get at classifying sounds. As we know, sometimes it's just too faint. You can say, it's a dolphin whistle, but I can't tell you which one, and neither can the machines. So do not be fooled by all these media articles. Where's media in this room? I know you're here somewhere. There you are. Machine learning is not like a miracle. It's just a useful tool, and it only gets you so far. But this sort of component of bringing in the background can really help. And it's important. These machines they're just looking at pictures, so you got to understand what part of the picture they're looking at, right? And in the end, it's actually worked incredibly well. Got 97% accuracy for Susan, 100% accuracy for Tedunkus, Tessiops tedunkus. Common dolphins, oddly, were a little bit worse, but this is a very useful tool, and it is available online. We had a bit of glitches with the code, but we're trying to get that back up and running, just because anything coded, of course, packages get out of date, etc. So we are going to do our best to try and keep that package available and optimize it and available for people to use. And then the last piece of work that Guy had worked on was sort of taking this back into the echolocation. So dolphins echolocate. They produce these clicks that are used to detect and measure and feel the world around them. And so this is a draft paper that's currently sitting on our desk that we will finish. It's a really interesting piece of work. Laser. Amplitude and frequency. So these are the different dolphin. I don't have the text on here. So heavy-sized dolphins are narrowband high frequency, so all the energy in their clicks is way up above 100 kilohertz, and the killer whales jump out very differently. They're obviously an 8-ton, 6-ton animal, so they're a very different body size to the other dolphins. Sorry, got to breathe. And so what Guy found working through this data is that there are quite predictable differences in various frequency bands that can be used for classification, and sort of putting this into a phylogenetic framework, so sort of feeding off the work that he'd done earlier. So whatever you start in your career, just be careful if you think about going to a PhD. It's like whatever you start doing, it's going to stick with you for the rest of your life. So choose wisely, young students. And yeah, nice piece of work, really sort of teasing out some of the differences you can see here, and that the measurements produced when run through a random forest support the phylogenies that we're currently using, and things like Lagonorhynchus is now being pushed as part of Sigmatius. Don't worry too much about it, but us dolphinologists like reshuffling the taxonomies every few years just to keep everyone on their toes. And the acoustics, interestingly, does support the genetics phylogenies, which is quite nice. So it's quite a nice sort of, it all fits together. You've got this one end coming in from the phylogenetic background and our current sort of what sounds are the dolphins making, dusky dolphins here in green have this very strong banding, which makes them quite useful sort of to pull them out. I'm running out of time. And yeah, and that's where it ends. I don't know if there are any lessons. The lessons, I guess, are enjoy life, do everything you can, say yes to everything. Thank you. Yeah, I'm even on time. Well done me.
Okay, so thanks very much, Simon. Is it appropriate to ask questions? It may well be. I think it's a good opportunity. Maybe ask questions about Guy, maybe ask questions about his work, and we'll do our best to try and answer them. So if there are questions, please raise your hand, or also online. No.
Hi, out of curiosity, do you know if when he spoke to fishermen and local communities, he was also looking at historical stories that fishermen would, pass down or tell, and historical knowledge that might not presently be applicable for species that might have changed their location or changed the way they do things? Just out of curiosity, if you guys might know on the off chance.
So the location that Simon showed you, Ilha de Fogo, in that location there was fishermen who were coming to the island. There's also fish people on the mainland as well. And so in that context, we hadn't really undertaken the work, but Guy was very, very keen to develop that. We actually found out that the people on the mainland spoke a different language. They didn't speak Portuguese, which was actually, so then he actually focused on the people on the island. But in general, I think then, yeah, you do want to dig a little deeper into the history. And if you can devise these ways of determining changes in, say, fish catches or distributions over time, then that's wonderful. It's just how do you orchestrate those interview methods that aren't imposing, that are that get at the information without constructing it in a way that is I guess off-putting or misunderstood, or you've got to do it quite carefully, and so that takes quite a long time period, I think. But what Guy had done in that trip in Ilha de Fogo was he actually changed the narrative on what what the fishermen were doing there and why they were there. That island was an island that was being developed for high-end tourism. It's a beautiful area, and it was owned by somebody from the States. And there was the potential for conflict between the fishermen who'd been there and the development. And he, by spending time with the fishermen there, understood that they'd actually been there fishing for at least 40 years, and that it was very much ingrained within their culture. He understood how much they got paid and how little they got paid. So he was able to actually, get this information that the people who were developing the island hadn't ever taken the time to really dig into, and why, what species they were targeting, and there were seahorses there and things like that. So to get these little glimpses of information, and I think that was where he was really advocating for the fishermen there, and that was the right thing to do, and that was very important in that visit. Yeah. Anything else? When we tomorrow afternoon session, we're also having a sort of creative special session, and again, that the input that Guy had didn't just come from science, but it also came across to music and art and so on. I think a lot of us find it at CSUH quite difficult to go through all the videos and all the photographs that we have because it's still quite raw. But he had a huge part to play in the project that will be talked about and demonstrated in tomorrow afternoon's session, where we're working with artists in April, we were at a bioacoustics retreat, so we were working with artists there, and that was a big part of his involvement there, was sort of crossing these kind of different disciplines, and I think that's where Simon's talk here has really tried to demonstrate that he, you know, you're not just good at one thing. It's beneficial to be good at lots of different things, and that's where Guy did really well. Anything else? No.
Yeah, would encourage you guys to join in the art session tomorrow. As hardcore scientists, it might sound a bit out of the box, but it really is worth doing, and a lot of the background of the story is about, yeah, you know, it's science. It's using sound as a way of, as outreach for conservation, and sort of how do we tell what we do to general populace who might not appreciate it. So, yeah, hope to see you guys at that session tomorrow. Thank you.